So hello everyone. So this is the second video of the series, actually mathematical logic. So I hope before watching this video, I hope you have watched the previous one which I uploaded yesterday, because see, these are all related. Okay, if you haven't watched that, watching this will be difficult. Okay, so if you don't know these topics, so I hope you have watched that. So I will continue with that only, with that you have watched. And if you haven't, please go and watch and then come back to this video. And if you like my channel, my videos, please do subscribe to the channel, not to the videos, like just to the channel. See, I cannot edit and see click the bell icon and all. So I am just requesting you to subscribe to my channel, so that it will reach more people and will give me the confidence that people are watching. So let's start. Okay. So yesterday we did implications, right? Then biconditionals, all this we have done. So now this is just equivalences relations. So it may look like such a big thing. See, you don't have to remember here this. These are just some commonly used, but you can just derive this. I will always suggest to derive, because when I studied, and then I was like, how can I just remember all this? I did. Look, I couldn't remember. I still don't remember. From my notes, I took out this and I have written it down. You can just you can take a screenshot. You can just make notes of it, of this, like this. This is my notes. You can, if you can see, like this. I have put it in my notes. So just for like safe I did. So after this, we will do some important topics. This is also important. If you can remember, that's okay. If you cannot, that's also okay. I couldn't, so you can easily derive. See, let's see. P arrow Q. This is, we know that complementation of P or Q. This is actually the first implication. Then, like this, P arrow Q can be derived like this. See, if we can derive it like this, Q, and I want to see this visible above. Yes, it is visible. So Q, like this. So what this means? P, let's say this is something, arrow something. Okay, so what is this? Q complement of complement Q plus P complement. So this is basically P complement plus Q. So this is also coming as this only. Like this, we can derive, let's say, another one. This number 3. So P complement arrow Q. P complement and complement P plus Q. Let's say P plus Q. This is all means plus. Okay. So like this. Let's say the next second, fourth one. So complementation. Okay. So this I have to do next video. So De Morgan's law. If you remember from other, I haven't done CDS, but De Morgan's law is used basically from very 12th standard or in UG standard. So I'll suggest, if you remember this, or in next, just after erasing this, I will do the De Morgan's law. But let's see this Q complement of this. So let's say Q plus P plus. Okay. So De Morgan's, what is saying, that it will of examples, so please hold on to that. Since I am doing mathematics in parallel, so I am telling you what is basically this. Okay, so in De Morgan's in digital logic we will do lot of questions on this, and also here we will do a lot of questions. So even if you are facing any problems with questions, it will be easier. Okay, so let's see some. Let's take an example. Okay, so this is our first example. Let's say Sudeshna has a computer and a phone. So this is our statement. So this statement can be broken down into two. We have done this. Okay, the statement first statement. Let's say P has Sudeshna has a computer. This is our first statement P. Then Q statement can be Sudeshna has a phone. This is our next statement. So now we can use that De Morgan's law. How? Let's say P into Q whole this complement P into Q whole. So PQ whole bar like this, which is equivalent to what? P bar, sorry, plus Q bar. So we can write it down as which was P. Sudeshna has a computer, which is complement of this. Sudeshna doesn't have a computer. It doesn't we are using because it is complement. Or see this class is actually or. So now Q bar. So Q bar Sudeshna has a phone. Now we have to complement it. Sudeshna doesn't have a phone. So Sudeshna doesn't have a computer or Sudeshna doesn't have a phone. Like this. Okay. So this is basically we will use this in questions also. And De Morgan's law is basically very important. So please make a note of it. Okay. So this is very important in digital logic also. We will do all this again, but here we are needed. So that's why I have done this. So please make a note of it. So now let's see here argument or inference. So let's see here. So now argument or inference. If a set of premises P1, P2, Pn yield another proposition Q, Q is called conclusion. The process is called argument. So if you remember P arrow Q, so P was our hypothesis, Q was our conclusion, right? Yes, conclusion. So here, if we have the premises like P1 to Pn is there, yield another proposition Q. Proposition means if it has any truth value. I have done all this in details in my previous video. Please, if you are not understanding, please go and watch that video again. Okay. So if I do again all this video will be longer, and those who have watched it will be boring. So I hope you that this is also I have done in my previous video. You can take a note of it. Now we'll move on to our rules of inference. So if you want, you can take a note of it. So now let's see this questions. Here the questions rules of inference. So now first is simplification rules. Okay, so all this you don't have to remember. I'm telling you all this because these terminologies are used. I think a lot of places are used, but I don't think you have to remember this. When I did, I thought I have to remember, but I couldn't. I still cannot remember from my notes. I just took it and wrote it down. But you can just derive it by doing the question. So I'm repeatedly telling you. You can make a note of it, which is important, but you don't have to remember. Okay, so let's see now. Simplification rules. Okay, so let's say P. So how I have written it down. So P into Q is valid. So both are valid because so P into Q valid means both have to be valid. Then only see if P is 1 and 1, then this is valid. Valid means like the answer is 1. Let's say the answer is 1 coming as 1. So when 1 into 1 it will be 1 only. 1 into 0 will be 0 or 0 into 1 will be 0 only. So this is the only possibility here. 1 into 1 is 1. So P and Q both values have to be 1. Then only P will be valid. So P is valid like this. So this is given. This is our given part. P into Q both is valid. Means P is also valid. Q is also valid. Therefore P is also valid here. So now let's see here. P into Q arrow P is tautology. Tautology means the statement is always true. Now let's see this statement here. So P Q whole part plus P. This is coming down to as this. See, we have done this so many times. P into Q. This is just simple. Let's say x arrow y, which is coming down to as x plus y. So this is our implication. Can be doing now like this. We have done this so many times. Okay. So now, according to De Morgan's law, this can be written as P bar plus Q bar plus P. Okay. So now this 2 P bar plus P will always give 1. Why? Because it will contain like the whole universe. Let's say P is something, P is 0. The P bar will always be 1. So 1 plus 0 is 0. 0 plus 1 is 1 only. So if P is 0, P bar will be 1, or P is 1, P bar will be 0. So addition of both this will be 1 only. Okay, so this is coming down to as this. So this is our tautology. Means it is always true. Whatever value we take, it will be always coming down to as true only. Okay, so like this. So you can see, you don't have to remember. You can just easily derive all this. Okay, so now let's move on to next addition rule. See, P is valid is given. So therefore P or Q will be valid because this or is like 1 or 0 will be 1, 0 or 1 will be 1 only. So P, sorry, this is the case here. So P is given as 1. So in yes, this is also correct. So P is valid means P's value is 1. So obviously P or Q will be 1 only. That's valid. Same way Q value is valid means 1. So P or Q will be valid only. So this is also correct. So all these are correct only. Okay. So still I am telling you how it is coming as true. So now let's say P complementation is valid means P bar is actually 1. So P bar is 1. So now let's see here. So this is actually P bar plus Q. So P bar is 1. 1 plus Q is 1. When 1 plus anything is 1. So this is also coming down to as valid. So now next Q is valid. So P arrow Q will always be valid because P arrow Q means P implication Q means P complement plus Q. So Q is already valid. So this is 1. So 1 plus anything is 1. So this is also valid. Okay. So now let's see number 5. Okay. So 5 is this whole thing given like this. So jumbled up. So I might write it down like this. Okay. So like this. So then P complement dot Q complement. Okay. So P dot Q remember this. So I have just taken from my notes. I have seen this written lot of times, but it's not possible for me to remember. So let's see the question. See, you can derive this very easily. P or Q. So P plus Q is given. P bar is given. So this is actually P plus P bar is 1. 1 plus Q. So it is basically 1. Also Q is valid also. Okay, so Q is valid because 1 plus Q. So it can be written as Q is valid only. Okay. So now next is conjunctive syllogism. So this is actually PQ whole bar. Then you can written as P bar plus Q bar. Then this is P. From this two you can take as this is 1. This part is coming as 1. 1 plus Q. So Q is valid. Okay. Sorry, Q bar is valid. So Q bar is valid. Like this we have done. There are some more. I will write it down. So you can see you can easily to derive all this. So this will be used in our questions, but you can derive. Nothing to remember from this. We can easily derive. So just make a note of it because practice is important. Okay, you cannot just jump into questions because practice is important. Then only you can do it easily. Okay, so please make notes down. So we will do more. Okay, I will erase this and I will write it down some more. So now more we are currently 9. So these are some more. So now let's see number 10. Modulus ponens or rule of detachment. So these terminologies are used. Let's see, it's recording on. Yes. So these terminologies are used. Okay. So you don't have to remember. I don't think you have to remember all this. So now let's see this. Okay. So this is valid. This is valid. How it is coming as valid. Let's say this is P. Implication to is P bar plus Q. So this is just P. So from this you can do P bar plus P is 1. So 1 plus Q. So Q is valid. Okay. So this is valid. So now modulus tollens or rules of contraposition. Okay. So now this is given as P bar plus Q is given. Q bar is also valid. So all this from this you can say this is actually 1. Q plus Q bar is 1. So 1 plus P bar. So P bar is valid. So P bar is valid. Okay, so transitivity. So this is very important. Okay, P bar, P arrow Q, Q arrow P will be P arrow R. So this is used in DBMS lot. So still we will do how it is coming. Let's say P plus Q, then Q plus R. So from this, let's say see this two will come down to as 1. Okay, so this will come down to as 1. So P bar plus Q. So this is basically P arrow R. Okay, so this is nothing just but P arrow R. So now 12 is done. Next is 13 dilemma. Okay, so this is P plus Q, then P bar plus R, then this is Q bar plus R. So you can see P bar this is 1. So then Q bar is also 1. So only left is R. So R is valid. Okay. So like this, let me check the statements once. Like this. Okay. So you can yes, this is correct. Then next is 14 is constructive dilemma. This is P plus Q, then P bar plus R, then Q arrow S means Q bar arrow plus S. So see R plus valid. See, you can say that P bar is actually 1 and Q is also 1. So this will come down as 1. So P bar is 1. So P can be 0 also. So P bar is here. Let's say P bar is 1 here. This is bar here. So this is bar is 1. Therefore P is 0. So this is not coming down to as valid. So this is actually not valid. Okay. So P is not valid. P bar plus Q same. So just given Q is valid. So now Q and Q bar. Okay, so let's say this Q and Q bar is going, just R is there. So now R and R bar is going. So S is there. So S is coming. So yes, this is true. So S is coming like this. So this is valid. So S is valid. Okay. So let's move on to our next question. So I think I have done some mistake previously, not this one, but see when we do this premises, this is basically multiplying, okay, like this multiplication. So I think in one previously I have said that class, this is not class, okay, this is all implications are this premises inside all these implications or whatever is given, these are all multiplication. So this p into p bar is basically 0. So p whatever it is, so complement of this will be 0. Okay. So please correct it in previously. I think I have done some mistakes here. I haven't seen my video yet, but when I was doing the expression, I felt like that I have done this mistake. So here like this. Okay. So this is okay, but previously like this r into r bar will be 0 like this. Anything into its complement will be 0 always. Okay. So in previously these are all multiplications. We have already seen the three statements which are equal. So one is what implicating all these premises. We have taken multiplication. Okay, so inside all these premises we will take multiplication only. So this is something I have done some mistake. So please correct it. I'm sorry about it. Really, really sorry. So apologize for that. So please correct it in your notes. So now this is very important. Okay, I hope you have corrected that previously mistake. I'm sorry for that. Okay. So this is very very important. Okay, so this quantifiers and negations. So two important terminologies are used: for all and there exist. Okay, so this is opposite. Opposite of A. This is for all. Okay, so this is for all and there exist. Opposite. Just E, mirror image of E. So like this. So for all means for every value that that if that it is correct, that value is correct, then only for all will say that is it is correct. For there exists means if there are a lot of like how to say. So there are some condition like this: p has 1 1 1, then 0 0 1 1 like this. So for all will say this is not true. Okay. So for all it has to be 1. So all the truth values has to be 1. Then only for all will say it is 1 correct. But in there exist will say yes this is true. For there exist at least there is one any one present. See everything can be 0 0 0 0 not 6 but 0 0 like this. But if there is at least one correct value is there, then there exists will say yes it is correct. So like this is very important. So now let's move on to our negation, how it is used and everything. Okay, so this is let's say this is our some premise px. So let's say px x has taken a course in CS and x means students in class. So this is just I am telling you what is px is. Px means x has taken course in CS and x means students in the class present. So now we are for all x px. See these terminologies are very very important because in questions this will be used. So now negation to this all this given. So how negation works? So this too is very important. Please make note of it because this will be used. This comes in questions also. Give. So let's say see this part we know we have seen for all x px. So now if we apply a negation to this, what negation does it? Negation just over for all it will change it to as there exists, and px will be changed to as negation of px. Okay, so how it is doing? Negation of whole this thing is coming. So for all will be changed to there exists, and this negation will go inside, and px will be turned to as negation means negating px. Okay, same is like this. Then if we apply negation to this what is there exists x px. So if apply outside, the negation is outside. So if we apply negation to there exists, it will change to for all, and the negation will go inside and it will be negation of px. Okay, so these are some important terminologies. This will be used, so I hope you please make a note of it, and this will be used. Okay, so this nothing much to remember or anything, just negation is moving inside like this. So these are really important questions will be asked. Okay, so I'm telling you this again and again. It may be boring, but it's very important. You have to do questions. This kind of questions are asked. Not this means this is just the beginning, but you will have to face more complex questions. Okay, now let's see. So now this is just examples we have taken. In this way we'll do questions also. Now let's see this first one. Okay, so negation is applied, for all is for all is applied on both. Okay, so for all is applied on this, and then negation is applied on this. So let's say take this is some Rx. Okay, so let's take like this. So first it's like you can take some example, but with help of more and more practice you can just directly do it. Okay, so for all will be changed to there exists x. Then I think yes, there exists now. Let's say r of x. Okay, like this. So there exists x. Now rx. Put the values px, negation of px into qx. Okay. So if you do remember De Morgan's law, basically this is p into q bar, which is p bar plus q bar. Okay. So this is De Morgan's law. We have done this. Okay. So you have already done this. So now it is coming down to us. This is equivalent to then px bar, you can select this px negation or qx negation of qx. So it is first applied to for all will be changed to there exists, then negation moves inside. So this is basically De Morgan's law. We have written it down, and will be changed to or, and this negation will be distributed over this. Okay, so now this is done. So let's see this. For all will be changed to there exists x. Now inside this, let's say px or plus qx. Right, let's write like this. Okay, so now there exists. This will go inside. See, this is negation is implied over whole. This is then we apply De Morgan's law. This will be changed as px dot qx. Not dot, actually it's better to write and qx. Okay, like this. So why I'm not writing dot, like because it is just terminologies used here, and this thing conjunction, I tend to forget all these names, but it's okay, you can write this. See, in gate options will be there, so you have to pick the correct one. So now let's say this, there exists will be changed to for all x. Now px qx, this there this negation will go inside. So this is basically px or complementation of x. Okay, so like this. Okay, so this can be changed again. Okay, so this can be changed again to like for all x. Then this is p complementation negation of p. So this is px arrow of q bar x. This can be changed again. See, since not let's write like this. Say p bar or q bar negation of q bar. This is actually implication only. So I hope this is understandable. This is very easy. We will use all this in our questions. So now let's see two kind of BCL, two kind of statement, English statement, how it is translated. Then we'll call it a day, and then next day we'll do PYQs. Okay. So I hope this is clear to you. So now let's see these two basic statements. Okay, so complex statement will be used, but let's see this basic statements here. So every student in the class has taken the course holds. So this is, let's say this is our class. This is our class. Some students are present. This is class. Okay, and this is, let's say, in this world only. Lots of students are present, but this is our class we are talking about. Okay, so every student in the class has taken the course OS. So OX, O of X is X has taken the course, and then for all OX means for all student this X has taken the course. So now X is the students in the class. So this class X is the number of students there. Okay. So now SX is X is a student in this class. So now if X is a student in the class, then he or she has taken the course. See, if X is already is the student in the class, then he or she has taken the course. So this statement can be written it down like this: every student in the class has taken OS course. Okay, so if X is a student in the class, he or she has taken the OS course. So now then for all, see, every means we have to take for all students. So for all is used, then SX arrow OX. So X is the student of the class, arrow OX means implication OX. So X is the people in the world. So X is just the people in the world only. And now like we have taken the world as our boundary. So now this is our writing it down like this. So if X is a student in the class, say X is a student in the class, student, then he or she has taken the course. So if you remember, if then can be written it like this. We have used this lot of times. So this English segment is coming down to as this. Okay, so like this. For every student in the class has taken the OS course, you can write it down. If the student X is a student in the class, then he or she has taken the course. So it can be written for all is used, because every means we have to take all the we have to take all students here, and SX arrow OX. Okay, so this is one type. Let's move on to this next type. Okay, so some students in the class has taken OS course. There are some students, okay, not all. Some students in the class has, see, like this. This is our class and this is our world. So some students in the class has taken OS course. So some means there exists maybe some. So like this is SX dot OX. Okay, so not implication. Okay, so this is very important. Implication cannot be used here. So some student in the class has taken OS course. Some into OS. This OS O of X. Okay. So these statements can be very confusing at times. I get confused too. So there is shortcut mostly used. So whenever every is present in the class has taken the course, every, and then you see, when every is present, you can use for all and implication. So this is it. And when some is present, you can use there exist and into. Okay, so like this. So if every is present, see, every is present, you can use for all, there exists, for all, and this implication. If some is present, you can use there exists and this and. Okay, so this is the statements can be confusing at times. I get confused too. So that's why most of the times this is our correct way to do this for all and implication here. There is and this arrow but dot end. That's a conjunction, I think. I forgotten the names. So it can be used most of the times. This will give you the correct answer only. But at times you cannot use any of this. Then you have to evaluate. We will do such questions, PYQs. Next will be see, we are at end of this. See, I told you at the beginning of this playlist. If you see the first playlist, I have told you the first one was mathematical logic. So see, in 2 videos I have covered most of this. The next thing you should do is PYQs. Okay, so for now, for today, if you are watching this, so you should do what please practice. See these 2 videos, practice it, and next you should concentrate on PYQs. Okay, so PYQs means get previous year's questions. So we will solve today. Not today, it's almost the days, so we can call it a day. And tomorrow we'll do PYQs. Okay, I will continue with algorithms also. So I just hope, thought that since I got mails and all, so let's continue with maths also in parallel. So if you want to reach me, okay, so text and all I may miss out. This is my email sudeshna135@gmail.com. So this is my email ID. Okay, sudeshna135@gmail.com. I will put this in my description box also. This is it. So we will do PYQs. So I hope you have watched these videos, and if you have loved, so please like and subscribe to my channel. And if you have any friends who are also preparing for GATE, and if they have seen in any their exams, semester exams, so please tell them about this my videos. So I'll be very thankful to you all. I hope these videos are helpful. And I did some one mistake there. P dot p5 is equals to 0. Okay, so dot will be used. Okay, so some but I just did plus. It's not plus, it's dot. Okay, so about this, I mean premises. In place of premises, some present p1, let's say p1, p2, p3. So these are all p1 into p2 into p3, like this. So in place of into I did plus, so this is wrong. So this is the correct. This is correct.